videos. They're all gone. I don't have them. They don't exist anymore. They went to the great bit bucket in the sky. Okay, so God bless them. Why they would do that without asking me first is beyond me, you know. But I will be taping the 687 courses and doing lectures and doing the same thing, putting them up on YouTube in case you're interested. So, okay, so how many of you? Is there anybody that has not yet successfully gotten Linux environment up and going? Raise your hand if you have gotten Linux up and going. So there's a few who haven't. Probably a third of the class hasn't yet. Lakshmi, have you gotten Linux up and going yet? Okay, good. So, if anybody has real trouble doing that, let me know. I had suggested I'm using VirtualBox and Ubuntu, and it seems to work reasonably well. So if I keep all the other processes from not running, I turn off almost everything on my machine, then I get reasonable latencies, and it seems to work okay. So as you'll see. So I want to talk a little bit about programming environments. This is going to have to be a discussion in two parts because I haven't gotten far enough along yet. You'll see why. We'll talk about it. So I will begin this process now and then come back and talk about it a little bit later on. I think we'll move some of the content that starts to prepare you for Linux. I'll talk a little bit today and more on Thursday. I'm sorry, prepare you for COM, prepare you for Project One. I'll talk about a little bit today and some more on Thursday. And then I plan this lecture and the next lecture were intended to be a fairly detailed walkthrough of system programming on Linux. And the material's there, but I wanted to give you interactive demos as we go. Just to instead of me just talking at you, I wanted to talk at you and then show you. And I am changing the way I do that. You'll see in a minute. So let's pull up, so let's start up Dropbox and get Ubuntu going. So I showed you, I think last time or the time before, trying to run Eclipse, and it was unusable. But between the combination of a small screen and high resolution rendering, the bitmaps that Eclipse uses for you to make choices on the IDE were so small you couldn't see them. And there's nothing you can do to make them bigger because they're bitmaps. So the latest version, it's entirely possible that the latest version, that version of Eclipse I think I got out of from the package manager, and so it's almost certainly not the latest one, maybe, but I'm not a big fan of Eclipse anyway. I want to run NetBeans because NetBeans is a reasonable alternative. One of the things you're going to use for Project One is my file system stuff. C++ standard libraries give you streams to manage opening and closing files. If you know where they are and you know their names, or you know what you want, great. But it doesn't give you any facility to look at directories and see what's there and navigate around and stuff like that. So I wrote these file system for Windows and file system for Linux. And the file system for Linux, a couple of summers ago, I wrote using NetBeans. And it was okay. A little painful, but it was okay. Let's pull up NetBeans. And I'm not going to pull up file system in it. I'll do a really simple. But this is a viable alternative for you. So this is Ubuntu 16.04. There is a new version out, 17.1, that I wanted to use because this is what's called the Unity interface, and they did some kind of crazy things in Unity. So I'm not a big fan of the Unity interface. And 17.1 will go back to GNOME, which is good. But unfortunately, if you go to the download page, they've disabled downloading 17.1 because it apparently is bricking some BIOSes on machines. So
17.1 got a different GCC version, is that okay?
Beg your pardon?
17.1 got a different GCC version, is that okay? Because I use 17.1 instead of 17.
If you've got 17.1 up and running, that's great. No problem at all. When I went to the download page, which was the last time I looked, was about 2 days ago, it had disabled the.
I use it every day for a long time.
Oh, okay. So, all right.
Because I think your page says we have to use GCC 5, but 17 they use GCC 6, I think.
Okay. GCC 5 is fine for all we need, but 6 is fine also, of course. So, yeah, either one. So if you have GCC, do you have it on this machine?
I think that's a count, not GCC. I mean my Ubuntu or GCC.
Ubuntu.
No, it's in my home computer.
Oh, okay. Yeah. So anyway, so this is NetBeans, and it's okay, you know. So here, let's look at main. So it's just a simple little demo program. So here, I wanted to use some threading stuff just to make sure that it was linking. So GCC 5 understands C++ 11 and has the pthread library and stuff like that. But you got to tell. You'll see in a few minutes. So this was just here just to make sure it would work. So this is just a little. Here's cout demonstrating NetBeans C++. I flush it for reasons that we'll see when we go through the debugger. And now I'm creating a thread running threadproc, and threadproc just says hello from threading world and flushes it. And then here I say hello world after starting this thread, flush it, join it, and then quit. Okay? So this was just when I first set it up was to make sure it would work. And there's some nagging little problems with it that I'll talk about in just a second. So we can run this thing. So let's just run it. Build successful, demonstrating NetBeans C++, hello world, hello from threading world. So thread was running. Got its output, cool. And we can debug it. So if you use the debugger, let me set a breakpoint here. Oh, I got a breakpoint set. So it's just like Visual Studio. You click on the border and it'll set a breakpoint. And so debug project. So here I'm sitting on a breakpoint, and now one of the things about, well, no, it's not happening here. So now I can step over. So let's just step over. So nothing yet. Okay, there comes my demonstrating NetBeans CPP. Hello, okay. And now the thread already ran. So I didn't step into the thread. I could have stepped into the thread and we would have seen it. So the thread already ran. And now we can step again and flush the hello world. And there comes the hello world and, join, and thread is already done. So, so the debugger, you can see variables and you can single step and you can step into, and okay, all that stuff is good. The main thing that kind of bugs me a little bit is you can set some kind of properties globally so it applies to all projects, but the important properties you got to set on every single project. So for example, I had to tell this, even though it's GCC 5, I had to tell it I want to use the C++ 11 standard, and I had to tell it to include the pthread library, and I had to do it in the project. And I started another project, I got to do it again in the project, and another project, I got to do it again in the project. Kind of annoying. It should be a global way to do it. There are global properties. I can come here on tools and come down to properties, and there are things I can set, but not those. And the way you set the properties is I had to go to Stack Overflow to figure out how to get it to talk to pthreads, because I did the obvious thing. So here is, here's the application properties. And so, here's my C++ compiler, and so, let's go to the, let's see, So I got to figure out, I don't even remember how I set the C++ compiler. How did I set? It's not these. You would think it would be. So I got to tell it where to put the, where to tell it the standard it's going to be using. I think maybe that's down below. I just didn't see it because it's down below. Yeah, here it is. Okay, C++ 11, and so, it was down under, and the pixels are so small, I didn't even see the slider. Okay, but you gotta, if you don't do anything, it comes up with default, and the default is C++ 98. Why would you set that to be the default, guys? Come on. But they did, so so you gotta pick 11. And now for the linker, we need to link to pthreads, and so here, always before, up until this version in the libraries, you just said -L pthread. But no, now you got to tell it POSIX thread. So what you got to do is, and you can't just write this in, you got to go, there's another / gives you, this many steps to get to that option. And you got to do that every time on every single project. So that's kind of clumsy and kind of awkward. And so I'm not a big, it's usable. You can do, it certainly is good enough for project 1. If you were going to do some Linux programming for your final project, you probably wouldn't want to use it. It's my take. Too painful.
That's it?
Yeah.
Is there any other IDEs?
I'm gonna do one. So there's Eclipse. The two main ones are Eclipse and and NetBeans, and I showed you that Eclipse was absolutely unusable on this machine, at least, you know, and with my old eyes, just unusable. And so this is reasonable, but I'm going to show you another one that does less and more, and that's VS Code. VS Code is kind of interesting. So let's go. Let me kill this. That's what I handed out. The handouts have to do with VS Code. So let's pull up. Here's VS Code. So Visual Studio Code. This is not Visual Studio, even though they called it Visual Studio Code. In some places in their documentation, they refer to it as Visual Studio Code. Most places they refer to it as VS Code, but it's not Visual Studio. Now, here's one of the crazy things that. So there's some menus. Let me get rid of this guy. There's menus associated with this. These up here on this top window are the menus that you'd normally expect to see on this application. That's what Unity does. Unity grabs the menus off the application and puts it on his main application, and kind of weird, and you know, it always confuses me if I haven't used it in a while. So, but so here's the same, essentially the same program, C++ 11 program. And let's go build it. So I will go here to tasks, and I will run the build task. And that just ran a build task that I defined. And as long as it succeeds, you don't see anything. You know, it just returns. If it fails, you'll see error messages here. So if you don't see a bunch of verbiage, then it built. And now let's debug it. So debug, start debugging, and this is another task, it turns out. So this is a breakpoint I set, and again, like always, you just click on in the border to set a breakpoint. And what you see here is the console output from this program. This is a console program, and so this is the output from the debugger. And so let's just single step through it. So nothing yet, but when I flush it, out comes demonstrating VS Code, and then my string message. So here, this variable said error up until I clicked this, you know, this said error. Now it says hello world. You see the values of the variables, because it's easy to see them. And so let's keep going. So I see out my message. You don't see it yet, but when I flushed it, now you see it. Now here comes the thread, and let's step into the. Actually, I won't, for reasons I'll talk about in a minute. So now I just ran the thread, and there's the thread. Hello C++. Hello, C++ 11 threaded world, okay, and join and, you know, return and blah, 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 and so done. If you want to see so this is like Solution Explorer. And what it does is it shows you the files and folders and stuff like that. I'm running this stuff on the desktop, okay? So, what was I going to say? So, and if you want to, this is the debug menu that takes you back. So, you know, so it's really easy to use, but let's take a look at these handouts. So these handouts are just these tasks. So let's look at the tasks JSON. Now, this is an array that happens to have one element in it. So this label build, so if I just run tasks here, if I just say tasks, run task, then it comes back with the only one it found. Here's the label, build, it's just this build. And if I had to find another task, I'd have a stack of these. And that's cool, you know. And it's really configurable, easy to make those changes if you know what to make. Okay, that's why I handed this out. So, so here's what's happened is the command is G++5, and this would work fine if I got rid of the -5. I started out with this to make sure that it was using the, you know, because I had two versions of G++ installed on this machine. So, but anyway, and now these are the arguments. So G++ -5 minus G says I want debugging, and standard C++ 11 is you know, and pthread library, and this is the file I want to run. Every time I change the file, I got to change that. And I don't know whether I can sequence them or not. I haven't gotten that far yet in my exploration. Okay, but I don't plan to do that anyway. I have no idea what group is really doing. Okay, but problem matching, the idea is that if you get errors, then it uses the compiler as it pushes the compiler at it to get the compiler error messages out. So, and it's really easy to, you know, I could just cut and paste this, you know, in again and tweak the test a little bit, and now as long as I had a different label, now I would get two tasks, you know, really, really easy to configure. And it isn't a, you know, go to Stack Overflow to figure out that, you know, 17-step sequence to set the property in the darn project. Okay, it's really easy. But at the blush of things, it seems like it's pretty limited because it's just going to run. As far as I know, I don't know that it'll run multiple files by sequencing. Maybe it will. But what I'm going to do is run make. So, pardon me, I tell you guys not to do that. Let me look at it. My son is in the hospital, so let me look at it. Just a robocaller. Fortunately, it's not terribly serious, but it's, you know, you always worry about your kids when they're in the hospital. So, I'm going to use make. So my command will just be make, and I'm going to talk a little bit about make this afternoon, in case you're not. Make is interesting. So really simple, actually. Although most of the treatments that explain make to you make it so complicated, you say, gee, this is complicated. It's really simple. You just have to have the right explanation. But anyway, the other thing about this is it's really lightweight. So NetBeans, a mess to install, you know, big, long, clunky. Takes quite a while to, you know, you click the, you know, you start it up and it takes a while to start up and doing all this loading. So this is just bang, there it is. Okay. I think this is built using the Electron JavaScript framework, is what I think. Don't know for sure, but Electron I had talked about very briefly, and then when we were talking about the final projects, is a JavaScript framework for building desktop applications, and the Atom editor, which I was also considering using. I'm going to use this one, but was built with Electron. I think this probably was too. This is JSON. This is just JSON data. You know, this is configuring, and there are extensions. And if you click this, it says C++. What you do is you get a build task that uses MS Build. And when I did it on Windows, I downloaded it on my Windows machine, and it didn't work because MS Build wasn't where it expected to, and I didn't bother chasing that down. I don't think it would be a big deal. But anyway, so I think the combination of using VS Code and Make is a great, you can debug stuff. This is using the GDB debugger, the visual version of the GDB debugger. And Make is really cool. Make is like a solution. Make does the same thing as a visual, the Microsoft Visual, the big Visual Studio solution does. Just ties stuff together. We'll look at that in just a second. So I want to continue the Linux programming by building, debugging, and looking at file system Linux with VS Code, and I'm not there yet. I will probably work most of this weekend to get all that set up and going, I think. With luck, it won't be that big a deal, but. So, why are you graying out? Did I lose my power? No, you got power. Just Linux doing its thing. So, so anyway, what I expect to happen is we'll probably toward the end of the day, actually fairly soon, I'll begin talking about some of the background for Project One, and Thursday, background for Project One, talking more about that, the components and stuff. And then next Tuesday, I'll walk through the Linux programming with VS Code in the file system and all that sort of stuff and look at it in detail. That's my game plan. Okay, so let's take a quick look at Make, at this really nice little demo. So let me just put this down in case some of you want to come back to it. So I've linked to a little demo, really simple little demo. Now, Make is a tool that looks for Makefile. You can tell Make that here's a file that I want you to run, a Makefile that I want you to run. But if you just say Make, it runs the first Makefile, Makefile, that it finds. Okay. So, and typically what you'll do is build a Makefile for each project. You're just building a solution, so for each development. So if you compile something by hand, so this little demo code, G++ main CPP, hello, factorial, whatever. Now, Make is declarative. So you define a target, and there can be more than one target. You can define a target and the dependencies, and then this tab are commands to resolve the dependencies. Okay. So basically what you're doing is saying, this is what I want you to build, and later on, here's how you build it for each type. And what Make does is, it just goes and looks for anything that hasn't been satisfied yet, it applies the rule. Okay. But if it's already been done, it doesn't do it again. So. And so here's that example. So now, typically all is the target, and what he's saying in this demo is, so I'm naming this thing I'm developing as hello. So this is going to be hello.out or whatever. Okay, and here are the dependencies for hello. Hello depends on main.o, factorial.o, hello.o, those object files. And here's how I generate them with G++, main.o, factorial.o, hello.o, okay. And then main.o, main.cpp, G++, compile it, main.cpp, Factorial.o you generate by compiling factorial. So he's breaking this up into a linking phase and a compilation phase, and it's always going from the last toward the front. Here's what I want. Here's what the main pieces, and then you're just working your way back until you've defined everything that has to happen. So that's that's the whole idea of make. And the other thing is I can define some symbols in make. So for example, here, if I define CC equals G++, and so I may have a whole bunch of stuff with CC's all over the place. If I want to change that from G++ to Clang, I just change this one line right here. Okay, and now it applies Clang to everything. And flags minus C minus wall. This is a famous, is basically demanding. I think it will fail on any warning. I think that's what wall does, if I remember right. It fails on any warning. So treat warning all as an error. And so now, CC flag. So $, you're just telling it, I want you to apply this. I want you to resolve this variable, and then I want you to resolve these flags. So it's an easy way to put together fairly sophisticated, fairly large, bunches of stuff. So, and my game plan is to use that for what I do. Now, I don't know whether I'm going to do a whole lot of development this semester. I'm definitely going to do the file system demo. What I'm going to do is run I have a little tiny test harness, a single user test harness, not a big machine loading deal, just a little test harness. And what it does is it lets you define tests, and it has an executor that'll execute each test in the context of a try-catch block, and then it has a tester that has a sequence of these tests, and so it just it runs through that sequence, running every test inside the try-catch block. So I don't have to litter my code with try-catch block. If it throws an exception, that test fails, and it just goes on and runs the rest of the test. Okay. If you didn't do that, then that exception would end. You wouldn't do any more testing. Okay. So my intent is to set up file system so that it does that, and I'll use VS Code. My plan is to use Make and VS Code to do that. Depending on how the presentations go, last year we had fewer people in the class than we have now, and by the time we finish the last, you do 3 presentations. By the time we finished the first presentation, it was time to start the second presentation. It was just the way it was. So if there's time, I think I will do a project like you guys are, and so you'll see me, doing. I won't do as big a project as you guys are doing, okay? But so, is anybody planning to do the tiny? Are you doing the tiny web server, client server?
I'm not sure if I do. I'm not sure.
Okay. If nobody does it, I'll probably do that one. And then I'll give the presentation just like you. So. But okay. So there's a few things here you might want to look at. You need a library and you don't know what its name is or how to find it. This is a little example of using the find utility. There's 3 ways to find stuff. One way is to run find, which looks at everything. So, you don't want to apply it to your whole machine. You'll apply it to some. So here I'm applying find just to this user directory, and I'm saying I want live, anything that starts with live and ends in A. That's what the way the libraries are named in Linux. It's just telling me all the libraries. Okay, so I have some idea. There's one way to find out what do I put on that library line minus P, whatever, minus. So there's two other ways of finding stuff. Another way is to use locate, and locate is faster, but it depends on a database. So as long as the database is up to date, it's really fast. And you can use it to find stuff on the whole machine. It's real quick, because it's looking at a hash table, okay? But if you're not sure it's up to date, you have to update the database, and that's slow, okay? Because it's walking through the whole, indexing your whole machine. That's what it's doing. Hopefully it's doing it in a smart way, I don't know. But and the last way is to use grep on the man pages. So the man pages are broken up. Man pages, if you don't, is there anybody here, does everybody know what man pages are? Is there anybody that doesn't? It's okay to say. So man pages are manual pages. They describe stuff, and they're broken up into several levels. So there's a man page for all of the C libraries. There's a set of man pages for all of the system commands. And a lot of the C library stuff are just very direct, delegations to a system call. And so using grep and specifying which one of those categories you want, it's easy to find stuff from the man pages. So that's a typical. Grep, you need to know how to use regular expressions if you really want to get the value out of it. There's a well-known guy, I've forgotten who it was, who said, if you have a problem finding matches on strings, you need to use regular expressions. Now you have two problems. Okay, because the language is quirky, and I don't remember. Nobody, So you need a cheat sheet, and I think I've linked to some of the cheat sheets. You're going to be required to use regular expressions for Project One, And C++ has a nice, for what you need, you don't need to know much. The C++ standard library has a nice treatment of regular expressions, and I think you'll find them easy to use. So. And I will try to, I think I've already linked to that somewhere. You want to know, this link, Linux POSIX library, describes to you most of the headers you're likely to want to use and what they do. So this is a really good source. When you're doing system programming, you want to make sure you remember this. Because the header, the includes, these are platform includes, and they're different. Some of them are C library includes, so a few of them look like what you're used to, okay? But a lot of them are, like limits.h and math.h and locale.h, those are in C++, that's limits and locale and math, okay? But, there's net, inet, and pthread, and regex, and sketch, and, blah, 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 blah. But, it shows you the header, gives you a quick synopsis. So I want to do this thing. So if you're working on the cross-platform libraries and your job is to build a process class, what do I need? This would be a great place to find out what headers you need. And also looking, the other thing to do is grep in the man pages for process. Okay, so. See if there's anything else here. Okay, good. So now I want to take a look at here. This link is a link to the cppreference.com. Their discussion of regular expressions. That's pretty good. It doesn't replace a cheat sheet, because it's telling you here's how you use the classes, and you put in the regular expression specification, but it's not really saying much about how you configure that specification. You need this cheat sheet. You know, this is a special character that says the match starts at the beginning of the line, or the match ends at the end of the line, or, you know, mixed case or whatever. So I want to start by looking at dynamic link libraries. So I'm going to do this fairly quickly because it'll be a reminder for anybody who took OOD. But if I'm going a little too quickly, slow me down. Okay. So because you have to build DLLs for Project One. We're going to build components, and a component is a piece of software that is implemented as a DLL, exposes an interface and an object factory. What a component is. And, you know, hopefully it has some reference counting to control the lifetime as well. So I'm going to run this fairly quickly, but, you know, if you need to slow me down and ask questions, that's fine too. So DLL protocol. So
Professor?
yeah.
By reference counting, you meant the shared pointer or something? By reference counting, did you mean by main shared pointer?
No, a shared pointer is how a shared pointer is a reference counted thing, but you won't. The object itself has to be reference counted. Okay, and so basically what you'll do is when you create it, the reference count is bumped by 1, and when you know you're done, you call release, and that decrements the reference count. When the reference count goes to 0, it kills itself. It does a delete contents of this. Okay. That's really what the shared pointer does under the covers, but the shared pointer is that thing over here, but this is inside this object. So let's look at, so this is a couple tiny little libraries, and I am going to load them explicitly and load them implicitly. So implicit loading, to implicit loading, I have to compile against a lib file. So here, no, not there. Well, I am compiled. I'm not finding it here, but what's going on here is when I implicitly load, when your code is running, when the main guy that is going to use the DLL is running and makes a reference that's unresolved, the loader, the code invokes the loader, and for implicit loading, a file called a lib with an extension .lib is created. That does not have the code in it. All it has are the import-export definitions. It's just saying this thing you want to import resides at this address. And so that call now can be resolved to that address. So when I build the static library, I get a lib file that contains all the code and the export definitions as well. But for a DLL, for a non-static, for a dynamic link library, it doesn't. The lib file doesn't have any code. The DLL has the code. So when I'm compiling against that lib file, it's just telling the loader, when you load this automatically, here's how you resolve it. When you explicitly load, your code is doing that reference resolution. So it doesn't automatically load. Nothing happens until that DLL. If you just made a call and didn't explicitly load the library, if you didn't compile against that lib file, it would fail. So you're telling it, I want you to load this library, and I want you to find this function and resolve that reference. And I'll show you. We'll look in the code and we'll see where that happens. So the other thing is, and this is different than Linux. In Windows, we need this decoration. So if in DLL has been defined, we define DLL decal is decal spec DLL export. This is just telling the linker that these symbols are being exported and put them in the linker, put them in the link map. And if it's not defined, we're importing it, and this tells the loader what to look for. Okay, so just before, when I include, this is a protocol.h, just before I include protocol.h in the DLL, I define in DLL, pound define in DLL, and so that'll make these exports. When the client includes it, I don't define in DLL, and so for the client, they're defined as imports. Okay? In Linux, as far as I know, everything is exported, always, by default. So you don't need to decorate it. And I think .NET does the same thing. I think .NET automatically defines everything. They do this under the covers for every single thing that can, be defined. Because you don't need to decorate the libraries in .NET that way, but you do in C++. Okay. So, and now I just have some functions: get int, put int, pass value, pass by value, pass by reference, make object, and gmake object. So I am decorating all of these, so all of these are defined. These are defined in the exports. There's a tool called dump bin you can run against your DLL, and you'll see those exports. They're there. You can, I could have, if I define DLL decal, I think I have to, I've forgotten, it either has to be here or here. But when you define it in the right place, I don't have to do this. I could just do it once there. Okay. I typically do it this way because I don't always want all of them to be exported, and I might change my mind, so it makes it easy to do. So I tend to do that. Now, I have a make object. This is in the this is like an interface. Okay. This is pure virtual functions, so it can't be instantiated, and it doesn't have a virtual destructor. Shame on me. It absolutely should have a virtual destructor. Arpit sent me an email about it. Okay, I will put a virtual destructor there. Okay, so but when I implicitly link, I can create this instance of the protocol class by calling protocol : make object. It's static, okay? So I can just say protocol : make object. And everything's hunky-dory. But when I am explicitly linking, now I have to define those functions, where they are. And what happens is C++ mangles these names, uses name mangling to overcome to help you implement function overloading. And so the name of this is make object void. But it's tokenized in this weird little, ampersand, pound, question mark, make object, blah, 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 weird stuff. And every version of the compiler, it's different stuff, doesn't stay the same. Nobody could remember to do that. Okay. So if I had, just 1 minute, let me finish this. So if I had to call this myself, I wouldn't know how to do it. So for explicitly loaded stuff, I provide a separate gmake object. So with explicit loading, I have to call this. I have to call these creational functions. Okay, so I've got to call them anyway here. But for explicit loading, I say extern C, and that's a promise to the C++ compiler that I'm not going to overload this function so it doesn't mangle it. So now I can just say gmake object, and it can find it. And we'll see in a minute, where that happens. Now, if I'm implicitly loading, I don't need this at all, because in truth, these names are, when they're binding to those names, they're using the mangled names, but the compiler understands the mangled name, remembers it. The linker understands the mangled name, remembers it. So they can communicate just fine. It's the human being that can't remember all those widgy little symbols. Okay, so this is for explicit loading, and this works just fine for implicit loading. And we'll get to this a little later on, but I haven't required you to, but I think it's a good idea for your components to load them explicitly. And we'll get it, when we talk about COM, we'll talk about that a little bit. Okay, so that's the protocol header. And if I look at the client implicit, so each of these DLLs just implement those functions. If we look at the client implicit, so here's the implicit load. I just come on, I say protocol make object. Now, I didn't have to bind to this. I just have to use it. The linker automatically bound those mangled names. Okay. When this was loaded, it was implicitly loaded. It was automatically bound. Okay, so I can call make object. But we'll see when we explicit load. I'll show you where. So I create make object, and now I can call, get in, put in, all that sort of stuff, and away we go. Now, explicit loading here's what happens in an explicit loading. I didn't compile against a live file, so the loader isn't going to do anything. I got to do the loader's job. So I say H module, this is a handle, remember handles from C++, So load the library, and I'm telling it where to load it from. I could have done a little file search here and looked in a place to load stuff, but this is just in this demo, it's just one specific thing I want to load. So, and I'm loading derived DLL. Now I have a derived 1 class, derived 1 and derived 2 project, but I have told the linker to use a name derived. So if I compile derived 1 as a DLL, it creates derived.dll. If I compile derived1.cpp, it generates derived.dll. If I compile derived2.cpp, it generates derived.dll. Same name. The reason I did that is I want to show you that just by recompiling it, it still works. It's like problem with the DLL. You take it off to the side, you fix it, you recompile it, you put it back in, you just copy the DLL over the old one, and you get the new one working. So what's happening here is I just have two slightly different ones, and it's just copying. When I compile it, it just copies over the old one, and away it works. So let's go on with this. So now I'm loading the library. Now here's the problem. Here's where I'm binding. I'm doing that linking loader's job here. I say, typedef protocol, this is just a function pointer. This is a pointer that returns, this is a function, a pointer to a function that returns a protocol pointer and takes no arguments. That's my creational function. Okay, you go look at the creational function, that's its signature. And now I say, I want gmakeObject to be that type of function equals get proc address hmod gmakeObject. Here is where, if I didn't say extern C, I'd have to put on all those widgy symbols. Because this, it's looking in the link map to find out. And in the link map, if I didn't say extern C, it would have all those widgy symbols there that I'd never remember get right. Okay, so now if not gmakeObject, get process proc address failed. So this is exactly what the loader does. It's exactly what COM does. Okay, so now I got I bound this function to this. This is a function pointer, and I'm just assigning the address from get proc address to that function pointer. And so now I can call it like a function. So protocol star b pointer. This is what I equals. Equals gmakeObject. So this guy's going to return that pointer. Okay, and now b pointer, blah 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 blah. No way, it just works. Okay. So, and I delete the pointer at the end, and I free the library. So that library management is important to COM because the one reason why the COM objects are written with DLLs is that there's code, like directory code, is used all over the place in the shell. Lots of things use that directory code. And so that code is shared, that one DLL provides the code for all those 15 currently running applications. And so you don't want one application to free it. So there's a reference counting mechanism in COM that says, I'm done with this, so it just decrements and decrements and decrements. And when it's all done, it sets a little symbol telling the COM runtime, when you're ready, you can unload this library. We're all done with it. Nobody's using it. Okay, and that's all built into the COM object. We'll see that when we talk about COM. So this is an enormous saving, both in the disk, because if I didn't use DLLs, if I use static libraries or just compile it all together, now what happens is on the disk, I've got all that code repeated again and again and again in all 23 applications that use that service. But with a DLL, I have that code is only in the DLL, not in the applications on the disk. And when I run various ones of these applications, there's only that one DLL in memory. That code is being shared by every single application, not the local data. Every guy has their own stack frame. Okay, but that code is being shared. And Linux calls that a shared library for that very reason. That's the whole idea. And so operating systems tend to use the DLLs lots, all over the place, because it is an enormous saving of both disk space and random access memory. And the more important thing is random access memory, because if you start filling up memory, you're going to get page faults like crazy, slowing everything down.
Professor, I have a question about the name mangling which you mentioned about
Yeah.
function overloading. So you were not overloading a function, right?
I wasn't, but C++ automatically mangles every single function name, okay, because it doesn't know whether it's overloaded in some other package. Remember that C++ just compiles one package at a time, one CPP at a time. And I might have overloaded in some other CPP. I might have. And so C++ has to mangle every single function name.
I thought it just it just for one class, like if.
Oh, no. Well, I mean, so that wasn't in a class, that was a global function.
That's
Okay. Okay, so.
Okay.
All right. So, and now the libraries, and so notice here my client, I pound included protocol.h, but there's no define above it. So I will import my specification will be import Decal spec import DL. Now let's look at the libraries. So here's derive1.cpp. So now, before I include it's a little better. Before I include this protocol.h, define in DLL. I'm in the DLL. Okay? So now what happens is now I'm going to export all those definitions. So everything that's decorated with DLL underscore, whatever, DLL decal, DLL declare. This stands for decal spec DLL export. So now, and that is determining what goes in the link map. In the link map for the clients, we'll see the decal spec imports. And for the link map, part of the link map for the DLLs, we'll see decal spec export. That isn't a C++ thing, that's a Microsoft definition, But, and again, in Linux, because as far as I can tell, everything is exported and everything is imported, you don't do any of this decoration. It makes writing DLLs in Linux a lot easier. Some easier. So now let's just run it, so that there's nothing much to these, little examples, real simple, trivial little pieces of code. So let's run the, so let's set the explicit load as the startup project. And now let's build everything. Now, just to make sure, I'm going to recompile, I'm going to rebuild DLL1. Now, it's complaining here. This is a warning because I'm writing two different DLLs to the same path, to the same name and the same path, and so it's warning me, but I want to do that. That's the point of this exercise. So now let's run it, and sure enough, derive one, blah, 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 derive one. Now let's just recompile derive 2. And now let's run it. Derive 2. Okay, so sure enough, I just took that deal. I didn't compile anything else. I didn't rebuild anything else. Okay, nothing had to be rebuilt. I just made it. I pulled it out, fixed my bug, copied it back in, application started up, and used the new stuff. So. Okay. Christina, how you doing?
Okay.
I know you didn't take OOD, right?
Nope.
Yeah, so, and all of this I talked about in OOD, so these guys are, this is just a refresher for, how many of you have not taken OOD in the class? Okay, raise your hand if you have not taken it. So, there's more than, I see some people who haven't taken it, okay. But anyway, there's at least one other person, Christina, who hasn't. But, so, you know, if I'm blowing anybody away, you know, ask questions. There's one other thing I want to demo before we go, because this relates to where we're going. I want to do factory for abstract product. And I want to look at, so let's go to SU. I'm on my laptop, that's why I can run stuff, but the structure is the same. CSC 775 code, project 1 help spring 18, okay, and here is factory for abstract product. All of those links that I had there in project 1 are related to project 1. So what I want to do, I've already started that up, but I want to show you a diagram that's in this packet. So let's pull up this PDF. So here's the model. Pretend that interface 2 and interface 1 aren't here for the moment. So I'm the client, and I have two different products that I may want to access. And they both inherit from this, they both inherit from this abstract product interface. And this guy implements, I didn't show it here, but this guy, product A, implements operation A, and product B implements operation B. And so, you know, I just get to, from that interface, I'll just use whatever, you know, if I want to use project A or, you know, operation A or operation, I just use them. And the factory, what the client will do is it'll say on the factory, create me one of these, you know, whatever I've called it, and it returns this interface, this abstract product interface. This is just an interface. I happen to name it abstract product, and we'll see why in just a second, but it's just an interface. And so this client gets a pointer to that interface. It's really a pointer bound to whichever of these objects it, you know, is, but, you know, you know, it's really bound to either this object or that object, but it's bound as its type is this abstract interface. So if I make any changes here or here to this, the client isn't affected at all. As long as this is a DLL, I can make any changes that I want. It still builds because it's just compiling against the text of this interface. Works just fine. As long as I haven't changed the interface of the factory, you know, I say, give me an abstract product, then it returns a pointer to that interface, no matter, you know, whether I change it or not, nothing happens. The build works fine. Now, the change has to be sensible for it to still work correctly. I mean, if my change threw an exception, you know, I would break the operation, but I don't break the compile. Now, Along comes your customer and says, oh, I forgot to tell you, but I need. Ugh. My interface language isn't rich enough to supply what the customer's new request. Remember that interface is giving me a language to use. And the problem always is to make that language good enough, strong enough, rich enough that you can do whatever you need to do. Customer came along and he needs something that just doesn't fit my language. There's no way for me to do that with my language. If I change the interface, I break every client that uses it. They have to, I don't break their design, but I break their build. They have to recompile. Because when I add that additional capability and I've changed that language, then I've changed the text that client uses, and so, and if it's 10 million lines of code, I got to find every place that interface was used in that 10 million lines of code and change it. So you really don't want to do that, and there's a way not to do it. So now we can come along and we can just create another interface. This is the darn that customer interface, okay, doggone him. But so whatever name, and now you add the language that's appropriate for that customer's activity. Now what happens is any client that doesn't need that new functionality just continues to use this guy and it works just fine. But and the factory is going to give this guy a pointer, but if this guy needs this new customer facility, he has to have a way of asking these products, give me a pointer to this other interface so I can call this new functionality. And it turns out that works. You can do it. And now, after you've got all that work and your customer is happy as a clam, your boss comes along and says, by the way, Arpit, I want to add this a little bit. You could do that. That's really easy. You can do it this weekend. Okay. So same thing. Add another interface and a mechanism to get to it. That's what this demo does. It's really simple. I'm not doing anything useful, but it shows you that I can at any time add a new interface and I can get to it. I query for an interface, and COM, that's a core thing. Every COM object has something called query interface, allowing me to ask this interface to give me a pointer to another interface. And it may return a pointer saying, I don't implement that interface, but you can ask for it. So we're going to do that. So let's see how that works. First of all, let's just run it and see how it works. So let's just run it. So here, I am using the main central interface, the one we originally started with, and now I'm using the new product one, the new interface for the client. But from that pointer, I can't use the interface for the boss. Now I get this second product created. I'm using the central interface, and I can't use the first interface, but I can get a pointer to the second interface. So what's going on is, let's go back to that diagram. So if I have asked the interface to let me use this guy, he multiply inherits from interface one and the abstract product. So I can switch to this interface and now I can use them. Because this guy inherits from both interfaces, so either one will trigger his operations. Yeah.
What is that? The concrete product A? Is that an
So the concrete, so this concrete product A started out in life just having the functionality to satisfy this interface. It implements operation A, and that's all it does. And this guy implements operation B, and that's all it does. But now, when the customer came along, he wanted me to add operation C. So now this guy implements both operation A and C. Okay?
Was that a class?
Yeah, it could be more than a class, but this is a class. Okay, but there could be other classes below it. But each interface has to have one class that implements the interface. That's the gateway to all that other functionality. So, in this case, the gateway is the whole functionality. But that's the idea. Good question. Make sense, guys? Akbar? You sure?
Yeah.
I'm skeptical. Okay.
Dr. Fawcett?
Yeah.
I don't see the point. So if the concrete product A implements operation C, what's the difference between having a product C that implements the same operation C? Instead, we have one concrete product A exposing two different interfaces.
Well, all I'm showing you, I'm showing you two things. One is that I might on this interface, I might want to access two different kinds of, there's really two different classes that are doing two different kinds of things.
Okay.
Okay, but the main point is that I'm showing you that we can add a new interface that we didn't know anything about. Did anybody take design patterns here? Yes, I know some of you did. Guess what? This is the extension object, right? It is almost, not quite, but almost the extension object. All right, right, Sandra? Lakshmi? Not exactly, but close, real close. Same idea, same thing's going on. Okay. Now let's see how we do that.
What was it? You told that the concrete product A is not implementing the operation B.
Concrete product A is implementing operation A, and now it implements operation C.
So it's not implementing operation B, so it has to implement operation B, right?
So what has to happen is, in my interface, I have to ask for this object or ask for that object.
Yeah,
You'll see in the code when
Yeah, I got that, but okay, yeah, you can see the code.
Yeah. So here's my interface, abstract product, and this time I got a virtual destructor. Okay, don't forget to send me the email because I want to fix the DLL protocol. I hate it when I tell people to do stuff and then I don't do it myself. And then interface 1, this is the new interface that the customer wanted, and interface 2, this is the new interface my boss wanted. Now, typically they would be in different files. I'm just trying to, this is a demo, so I'm not putting them in separate, but typically they'd be a separate file. Although actually COM doesn't put them in separate files. So here's the concrete product at H. Now, so concrete product A derives from abstract product, and now, because I'm trying to satisfy my customer, it's implementing interface 1, and so so now I have operation A and operation B and oh, I'm sorry. So one object, they both of the original objects implemented op A and op B, but they did it in different ways. They did different things on those operations. Okay, I had forgotten that. Thank you. No wonder you were confused. So, they have to, right? Because it derives from the inherits from the interface. It has to. So, yeah. So you were saying, what's the guy talking about? So, and here's concrete product B, op A, op B, but now op D that he gets from the boss's interface. Okay.
Professor?
Yeah.
Could you please paraphrase this question once again, like you mentioned something about it? why can't we just add the same new functionality in the interface? Could you please paraphrase this question again?
I don't remember.
So instead of having concrete product A and B, we have another concrete product C and implements the new functionality. So what's the advantage like?
So what we're really trying to do, what we do with the concrete class.